I recall. Okay, so let's read the second statement. Let's write it down. I'm reading for you to write it down. So the second statement says, anyone who comes to this country, from Wuhan must be quarantined. Anyone who comes to this country from Wuhan must be quarantined. Full stop. Also, people coming to this country from Nigeria must be taken to Kumasi. Also, people coming to this country from Nigeria must be taken to Kumasi. Full stop. But people coming from Togo must be denied entry to Ghana. You see, the statement is getting more complex. Anyone who comes to this country from Wuhan must be quarantined. Also, people coming to this country from Nigeria must be taken to Kumasi. But people from Togo must be denied access to this country. Let's see how a programmer will use an if and then statement to program the above. So a programmer will say, if, then he will match people coming to Ghana. People coming to Ghana also match people coming from China. Also match people coming from Wuhan. You see, we have categorized people coming into Ghana and from China and from Wuhan, logical and vertical direction. People coming to Ghana and from China and from Wuhan. Everything must match in the logical end. What do you do to them? What do you do to those people? It says, then is the same as set. What? We are going to set them, or we are going to quarantine them. Quarantine. You see, that is our first statement. Let me call this one sequence 1. That is sequence number 1. Something has covered my if. Let me put the if here. Now there should be another statement for people coming from Nigeria, isn't it? So that would be the sequence number 2. Sequence number 2, another if. So now this if, I'm going to match anyone coming to Ghana. So match people coming to Ghana I'm also going to match people coming from Nigeria. You see, I've categorized these people. So what do I do to them? Then I'm setting them to where? What am I doing to them? Go to Kumasi, isn't it? Go to Kumasi. So if you come to Ghana, sequence number 1, if you come to Ghana, you pass through this process. You come from Ghana, yes. You come from China, no, you don't match. Quickly, you come to the second statement. Are you coming to Ghana? Yes. Are you coming from Nigeria? Yes. Okay, you will go to Kumasi. You understand? Now, let's go again. For somebody coming from Germany, are you coming to Ghana? The first statement will be checked first. It's always checked first. The first sequence number. Are you coming to Ghana? Yes. I just entered your country. Are you from China? No. You go to the next sequence. That's sequence number 2. Are you coming to Ghana? Yes. Are you coming from Germany? No. So, what will be done to you? There should always be another statement for all other traffic, which do not fit the category. So we need to put that thing in mind. Okay, so now people coming from Nigeria are now taken to Kumasi. So from our statement, we also have another category of people from Togo, and those people must be denied entry. So there is another sequence. Let's call it sequence number 3. So another if statement, match. If. Now we are going to match people coming to Ghana again. If people coming to Ghana, and also match people coming from Togo. Let me continue up here. So once we've matched these 2 people, what do we do? Then we are going to set them. What do we do to them? Deny entry. Deny entry.
Yes.
Yes. So we have done according to the statement. The programmer has done according to the statement. But as I said earlier on, there should be another if statement for all other traffic. So this time, if match people coming to Ghana, then you are allowing entry to all of them. So this final statement will define what to be done to traffic which do not meet first sequence, second sequence, and the third sequence. So the man coming from Germany will be processed with this sequence number 4 that says, okay, you are coming to Ghana, fine, you'll be allowed entry. That is the logic of route map. Okay, it's actually a programming language. So this is how a programmer will put it down. What about the network engineer? For us, we are cool with access control list. So we are going to define all this traffic with access control lists. Okay, so let me write down a vulgar access control list. Vulgar meaning iOS will not accept that access control list, but I'll write it anyway. So let me write down a vulgar access control, vulgar iOS language. Okay. So now the network engineer is coming to do his job. The programmer has finished doing his job. So the network engineer says, configure terminal, access list, 15, permit entrance to Ghana. We have just categorized people coming to Ghana, all of them, anybody, whether you come from Germany or whatever it is, you fall under this access list 15. Okay, so access list 20, they are just defining people. Please let me use this, okay? The writing is too much. People coming from China. Access list 30. We are permitting entrance from Nigeria, Wuhan, sorry, Wuhan. Access list 40. Permit entrance from Nigeria. We are still categorizing the traffic. What about the Togo people? The Togo will be slightly different. So we say access list 50, deny entrance from Togo. For access list 50, our first statement says deny. So we must bring an implicit permit any. If you don't bring permit any, the implicit deny all will affect this access list. So we want to avoid that. So for this particular statement, because I started with deny, I would like to add permit any just for the access list number 50. I've categorized the traffic. So I'm now coming to write route map statements for this traffic. So route map, you always do it from a global configuration mode. So configure terminal routes dash map. You have to give it a name. You have to give it a name. The name, as I said, has to be descriptive. It will help you in troubleshooting. So let me say no Koro, no underscore Koro. That is the name. There's a permit or deny any. You either permit or deny, followed by the sequence number. So let me just say permit. Somebody will ask me, why do I use permit all the time? You will know. It's so comfortable using the permit. You can use deny as well, but using deny in conjunction with access control is, you have to know certain tricks, otherwise you always go wrong. So my sequence number is 10. Permit 10. Then my next statement is, I'm going to match IP address. Anytime you see IP address, know that it's referring to an access list. People coming from China, to Ghana, anybody coming to China. So IP address, access list number 15. It must match. Second, you must come from China. So match IP address 20. Third, you must come from Wuhan.
I'll be going off in a moment. I'll come in with another device. Please, when I come, allow me. Thank you.
All right, thank you. Match IP address 30. I've just categorized people coming to Ghana from China and from Wuhan, logical end. everything must match. It's different from logical or, which we'll talk about later. What do I do to this traffic? I have to quarantine them according to our statement. Our statement says anyone who comes to this country from Wuhan must be quarantined. So I say set quarantine. Yes. But I have to make another statement with a different sequence number to define people coming from Nigeria. So I would like to exit out of this mode, come to the global configuration mode, and continue with my statement. So for lack of space, I'm going to delete some of the stuff on the board. So let me delete this part. Now we have to define, make a statement to define people coming from Nigeria. So another if statement, in this case, a second sequence number. All right. So route map, same name, no Koro, no underscore Koro. This time permit sequence 20. That's my second line. Then what am I going to match? I'm going to match people coming to Ghana. So match IP address 15. Also, which match again? 40. Access list, people coming from Nigeria. So match IP address 40. I've just categorized people coming to Ghana and from Nigeria. Come to Ghana and everything must match. If you come to Ghana and you are from Germany, you don't fit in here. So I won't take you to Kumasi. So it says what? Set, go to Kumasi. Go to Kumasi, okay? Go to Kumasi. I just completed my second sequence. What about, according to our statement, it says it has another statement for people coming from Togo. Yet still, we have to make another statement for other traffic, which doesn't fit this category. So people coming from Togo. So let me exit and make another statement. Route map, same name, no underscore Koro. Permit sequence 30. That's my third line of statement. Now I'm going to match everybody coming to this country. Again, so we'll match IP address for access list number 15. It says entrance to Ghana. Access list number 50 defines people coming from Togo. So I'm going to match IP address 50 for access list number 50, which defines people coming from Togo. Then my statement says what? The set says, what should I do to them? Deny entry. Deny entry. Yes. Now I've categorized people coming from China over here. I've quarantined them. I've also, by my second sequence number, categorized people coming from Nigeria, and I've taken them to Kumasi. I've also categorized by my third sequence number people coming from Togo, and I have denied them access. What about the rest? So I make another statement, route, map, same name, no Koro, no underscore Koro for sequence permit, sequence number 40. That's all. I don't even make any match. Automatically, it will permit all other traffic. That is all route map is about. But you are not going to get used to route maps in a single day. It comes with practice. Okay, it comes with a lot of practice, as I said earlier on. So we've spoken much. If there is no question, let's do some configurations on route maps to make our understanding firm. Yes.
Route map, right? How different is that from DPI, deep packet inspection?
How different is it from packet inspection?
Yes, deep packet inspection, DPI.
Oh.
See some similarities over there. That's what I'm asking. Is that what goes on behind?
Not really. Not really. Deep packet inspection is this time you are telling the router to. Deep packet inspection is. How do I even put it? You know, access control is a form of packet inspection.
Yeah.
Yes, access control list is a form of packet inspection. So if you are denying traffic based on layer 3 information, you are actually denying based on packet inspection. But you can go on further to deny based on port numbers. You see, that's layer 4. If you enter layer 4, if you have entered deeper into the packet, you understand? So me, I see deep packet inspection as a general statement. You understand? That is how I see deep packet inspection. So this time, you are denying access based on port numbers, not IP addresses. You have entered deeper inside the packet. I hope you are getting me. So I'll say that once route map also comprises of access list in a way, it also does packet inspection. You understand? It does packet inspection. So deep packet inspection is a general statement. Okay?
No.
Mulai, are you okay?
Yes, I'm okay.
All right. So let's move on. Take this. How do I take this thing? All right. So let me bring up this topology that I did. Yes. Very beautiful topology. Let's do the configuration together to see how beautiful we can use some aspect of route maps, how we can apply. So over here on this topology, I have router 1, router 2, and router 3. Router 6 is here, and router 5 is also here. Router 1, 2, and 3 are inside the EIGRP50 domain. So 1, 2, and 3 are in the EIGRP50 domain. And take note, router 3 is a border router. in the sense that one interface is in the EIGRP domain and the other interface is running OSPF, area 0. So when you are configuring this router, this interface will run EIGRP and that interface will run OSPF. But this router, all the other interfaces are running EIGRP. Over here, where we have EIGRP here. But in this topology, let's look at the case study. Are you in class? Are you in class? Okay, we have the topology here. And the cases: configure R1, R2, and R3 to run EIGRP 50. So R1, 2, and 3 are going to run EIGRP 50. But on R1, let's see, the 110.x.x network must be advertised by EIGRP. So if you look here, these are loopback interfaces. We have the 100, IP starting with 100 and those starting with 200. But our task is telling us that we should advertise the 100 in EIGRP. So router EIGRP 50 network, the 100 networks will come. But the 200 networks must be redistributed as foreign networks inside EIGRP 50. That is what we expected to do. So we are going to redistribute the 200 networks inside EIGRP. So, yeah, 1, 2, 3, all of them are going to run EIGRP direct. But over here, we are going to redistribute connected. Connected in the sense that we have actually configured the IP addresses on R1. So they are showing as connected routes. Okay, let's go back to the topology. So let me open R1. I've already configured them with IP addresses. So on R1, enable and show IP interface brief. So everything shows here that I've configured the loopback interfaces and also this 40 interface. So let me show the routing table. Show IP route. I have all these routes here as connected. See, on R1, the 100 and the 200 are all connected. So if I'm able to advertise this 100 in EIGRP and I say redistribute connected, all these 200 networks will enter the rest of the routers because they are connected routes. So let me go to this router and configure terminal router EIGRP 50 network. Now the 100 networks, you realize that all of them start with 100.10 in the first and second octets respectively. But the third and fourth are different. So I want to go the shortcut. So I say network, advertise the 100 and the 10, but the rest don't bother. So my wildcard bit says the first octet, take it serious. The second octet, take it serious, but the third can be anything. And the fourth can also be anything. I'm using wildcard bit here. So first two octets, 110 will go. Enter, Then the other one is network 40.0.0 and .0. It's a /30, so the wildcard will be that. Let me give it 1/3 minutes. This, we are done. Let me save. I go to this middle router, router 2, and configure EIGRP, just advertise these two networks, directly connected networks. So over here, enable, let me verify the IPs, show IP interface brief. Okay, just 2 IP addresses, no look back. So go to the global configuration mode and router EIGRP 50, network 30.0.0 and .0 for the wildcard of this, and network 40.0.0 and 0 for this. Yes, so we have seen new adjacency with the 40 network. That's a good sign. We go to R3. This time we are only going to advertise just this network. This is in the OSPF domain, so we have not come there yet. Okay, we'll come there. So on R3, show IP, interface brief, and I have just 2 IP addresses, which is okay. So configure terminal router EIGRP 50, network, just the 30 network, so 30.0.0 followed by the wildcard. That's all I'll do. I expect to see good, but that's a good sign. Now I've done what the question is telling me to do. The question says, okay, so now the 200, we have not done anything to the 200 network, isn't it? We only advertise the 100 network. So let's check the routing table of R2 over here, this middle router, to see what routes that we have received so far. So on R2, show IP route, and we are receiving the 100 or 10 networks. EIGRP, you see D? EIGRP is bringing them back. We have not seen the 200 network yet. So I'm going on R1 to say redistribute connected. For R1, I'm going to configure redistribute connected inside the EIGRP domain. So redistribute connected. I expect to see the 200 routes inside R2. So let me enter R2, check the routing table again, and I'm receiving the 200 network, this time as external routes. Okay, let's take note of the administrative distance here, 170, because the route is external to EIGRP. So that is it. We have done what the question says we should do. Now let's move on. It's asking, does the routing table in R2 display external routes from R1? Yes, it's displaying. We just saw it. Okay, question 3. Using distribute list with route maps on R2 prevent R2 from receiving the EIGRP external routes from R1. You see some of the flexibilities that route map has. Prefix list cannot achieve this purpose. neither can access control list achieve it. So route map is so flexible. We are going to use route maps to prevent R2 from receiving this external route. So this R2, we don't want to see this. Okay, our policy, our company policy says we don't have to see any external route. So imagine a world without route maps. Every router will receive every route. Every router will receive. Yes.
Please let me ask a question.
Okay.
You said we don't want to see the EIGRP external routes.
In R2, yes.
Yes, then why then did we even advertise it into R2 anyway?
Okay, good question. Our purpose here is to practice route maps. You understand? We just want to get our hands on route maps. What some of the things that route maps can achieve. Robert, are you understanding?
Okay.
So we are doing anything crazy just to practice route maps. Okay?
All right.
All right. So for this solution, see how it is tackled. So that is the syntax. We do the configuration on R2. And watch here. I went on the global configuration mode. I entered the route map mode, and I created a route map, and I gave it a name. No external. This is just a name. It can be any name. Then instead of permit, I said deny, followed by my sequence number. Okay. Now I came to this mode, the route map mode. Then my match statement says match route type external. Match route type. So we don't always match IP address as we saw when I was demonstrating. No, the match criteria are a lot. So this time we are not going to match any access list. After all, we have not even configured any access list. We are matching external routes. Then I exited. After that, I created another